Hello everyone, welcome to the first tutorial on a series of tutorials where I'm going to talk about how to create 3D objects from scratch. I'm going to be using Unity for these tutorials, however this is more of a computer graphics tutorial and less of a Unity tutorial. The concepts that I present here are going to be applicable in other 3D environments as well, for example 3JS. We're going to be talking about coordinate systems, data structures, and a few very simple examples of very simple 3D objects. So about coordinate systems, there's two kinds that we're likely to encounter, which is either the left-handed system or the right-handed system. On a left-handed system, which is for example used by Unity, when X is right and Y is up, the positive Z-axis can be considered the forward direction, and on a right-handed system, when X is right and Y is up, the negative Z-axis can be considered the forward direction. And it's important to note that when you multiply two vectors or take a cross product, the direction of the vector that you get changes depending on the handedness of the coordinate system that you're using. So it's more like the role of the vector changes based on our perception of direction within the coordinate system. However, the math for multiplying vectors or multiplying matrices, that does not change. That's still the same. So how do we represent a 3D object in memory? There's different ways. For example, there's point clouds, there's a polygon mesh or a triangle mesh, there's splines, there's constructive solid geometry. You could use sign distance fields to represent 3D shapes. We're going to be looking at a triangle mesh here, which is, I think, the most common way of representing 3D surfaces or 3D objects. And oftentimes, even when you're working with the other kinds of representation, you have to convert your model into a triangle mesh, for example, when you want to bring it into a game engine, or when you want to send it to a 3D printer. A triangle mesh, or a collection of triangles, can be represented using two arrays. So this is a collection of triangles where each triangle has three corners or three vertices, and these vertices can be shared among triangles. There are two arrays that help us represent a triangle mesh. The first array is a list of vertices, and then the second array is an index into the first array to specify the three corners of a triangle. For example, in this example triangle, the first array simply holds the coordinates of the three corners, and then the second array holds integers 0, 1, and 2 to specify that the triangle is composed of the first, second, and the third vertices in the vertex array. So one thing to note here is that all of these triangles have a front side and a back side, and it's important to note the order of vertices when you specify the triangles in the index array. For example, on a left-handed system, when you're looking at the triangle from the front of the triangle, the indices should be on a clockwise order. And on a right-handed system, when you're looking at the triangle from the front of the triangle, the indices should be on a counterclockwise order. So let's head over to Unity and create a bunch of triangles. I'm about to create a new project in Unity. I'm going to call it Triangle Mesh Example. And there's a bunch of templates that Unity provides. There's a 3D template and a URP template and an SDRP template. It doesn't really matter for this tutorial because it's going to look exactly the same. So I'll just use SDRP because this is the fanciest Unity can get, and I'll create a new project. So here we have an empty Unity project, and let me explain the pieces of UI and the components that we need from Unity in order to render a 3D model. The first important bit is this hierarchy window on the left, which contains all of the objects that we have in our scene. This is essentially a scene graph, and every object is a node in the graph. For example, there's a light called the sun, and there's a camera. There's another object that contains the post-processing effects. And whenever you click on an object on the hierarchy, there's an inspector to the right which shows all of the components of that object. And every object in Unity has a transform component, which is basically the position, rotation, and scale of the object. And you can have additional components attached to the object which lends different behaviors to those objects. So let's take a look at what we need to render a 3D model. I'll show an example of rendering a simple cube. Like if you right click on the hierarchy, and there will be a menu for creating some very simple 3D objects. I'm going to go ahead and create a cube. And now we have a cube in the scene window. And you can move around in the scene window. You can rotate around the object by using Alt click, and you can zoom in and out using Alt and right click, and you can use the middle mouse button to pan around. And then once you have the object highlighted in the hierarchy, you can change the properties of the various components that are attached to the object. For example, I can change the position of this object in the transform component, and it moves in the scene. It moves to the origin. So notice that there's a couple more components attached to this cube. The ones we need are the mesh filter component and the mesh renderer component. The mesh filter is the component that holds a reference to the mesh, the actual geometry that's being rendered, and the mesh renderer is the component that's responsible for assigning a material and controlling various aspects of rendering. For example, turning shadows on and off. For anything to be rendered in Unity, this mesh renderer component must be present, and we need to have a material assigned to the mesh renderer, and this controls the appearance of the object. And we can create our own material. For example, if you go to the project window, there's a folder called assets, and then if you right click on it, you will get a menu create, and inside this menu there's a thing called material, and I'll call it green because I want to create a green material. And when I have this material selected, you will see all of the options that you can change for this material. So material essentially is a shader, and all of the options that the shader supports. You could write your own shader, and you could write your own customizable shader properties that show up in this inspector UI, and you can change them. For example, I can change the base color for this object using this color picker, and I have green. And now I can assign this green material on the mesh renderer component of the cube. And I can do that either by dragging and dropping the material from the project window to the inspector, or I can click on this little circle here, which will give me a search box where I can search by name. And I can search for green. It will show me a material. I can double click on it, and now we have a green material assigned to this cube. Now let's write some code to generate our own geometry. To do that, we need to create a C# script by right-clicking on the project window. And when I do this, this created a new file for me. I'm going to name it triangle generator. And once this file is created, I can double-click on this file, which will open the code editor. So this is the class that was just generated. And notice that this class is extending from something called monoBehavior. This allows us to attach this behavior to any object in the Unity scene. For example, I can create a new empty object in the scene graph. I'll call it triangle. And notice that it doesn't have any components except for transform. And I can click on add component, and I can search by name for the script that I just created. And then once I click on it, now this behavior is attached to this object. Let's take a look at this script. It has two functions called start and update. This start function is called once at the start, of the application when you hit play, and update is called every time the frame is updated. So for this exercise, we're just going to use the start function. We don't need the update function, and this is where we're going to generate our triangle. Let's start by creating a triangle on the ground or the floor. And by looking at this gizmo in Unity, we know that the ground is the XZ plane. So we'll start by creating the data structure we need in the form of a new class. I'm going to call this class triangle mesh. And what I need in order to specify the geometry of a triangle is a list of vectors, 3D vector, which is the coordinate of the different corners. And I'm going to call this vertices. I'll also make this a public variable. And we also need a list of indices that specify the corners of the triangle, which is a list of integers. I'm going to call this indices. So we have the data structure, and we also need to initialize these variables to avoid a null pointer exception. So I'll do that right here. Let's create the vertices for our triangle. The first vertex is at 3, 0, 5. The second vertex is at 6, 0, 0. And the third vertex is at the origin, which is 0, 0, 0. And let's add these vertices to our list of vertices. For that, I'm going to need a new triangle mesh object. And I'm going to add these things to the vertices list. Now let's also populate the indices array using the clockwise winding order, because we're working on a left-handed coordinate system. And we're going to do that by mesh.indices.add the index for the first vertex is 0, and then the index for the second vertex B is 1, and 2 for C. So we have completed the definition of the geometry of a triangle. Now we need to feed this into Unity to the mesh filter component, which is what holds the mesh. And we can force Unity to make sure that these components are present in the object that we want. Because notice that this triangle object right now only has a transform component. It does not have a mesh filter or a mesh renderer, but we can enforce Unity to do that for us. And the way to do that is by using an attribute on top of the class called require component, and give it a type of the class that it needs to enforce to be present. And we need mesh filter, and we also need a mesh renderer. So this tells Unity to create instances of these objects when we need. And now we can get a reference to these objects inside our start function by doing something like mesh renderer equals this dot get component, and inside angle brackets the type of the component, and mesh filter equals this dot get component, the type is mesh filter. Now let's feed our geometry into the mesh filter component. And there is a property called mesh inside the mesh filter, which is where we're going to upload our geometry. And I want to go into the details of things like memory management and garbage collection, which are kind of important to know if you're working on a larger application. But let's just keep it simple for this tutorial. And what we're going to do is, inside this mesh component, there is a function called set vertices, into which we can give the list of the vertices that we just created, which is mesh.vertices, and then also set meshfilter.mesh.set indices, and give it the list of indices that we just created. But this set indices function, it takes more parameters, and the IDE should tell you what those parameters are. So the second parameter specifies the topology of the mesh. So this list of indices could either represent a list of lines or a list of points, a list of quads or a list of triangles. And we're using this in the sense of a list of a triangle. So we're going to use the triangle topology. And there's a third parameter which specifies the submesh, which we can just set to 0. In this case, Unity supports multiple submeshes inside a mesh, and you could choose to render those submeshes differently by using different materials for all of them. But let's not worry about that right now. There's one more thing we need to do to get this triangle to render properly, which is to assign a material to this mesh renderer. To do that, I will first declare a public variable of the type material. I will call it mat. This is a property of the triangle generator. And inside the start function, I can assign this property to the mesh renderer. So mesh renderer has a property called material equals this.mat. And this way we can pass the property from the triangle generator to the mesh renderer when the start function is executed at the start of the application. Let's go back to Unity and use this. So Unity just recompiled our class, and now I'm going to click on the triangle object, and so notice there's a new property called mat that shows up in the UI. Now I can drag and drop the green material to this property and let's hit play. So it switched to the game view and we don't see anything, and that's because of the camera angle. But if I go back to the scene view, we can see that there's a triangle in the scene, and this triangle is relative to the local frame of reference of this triangle object, which is not in the origin. And I can change this to 0, 0, 0, and this now matches the coordinates that we wanted this triangle to have. Let's look at how we can use triangles to compose more complicated shapes. For example, a square is two triangles. A regular polygon like a pentagon or a hexagon can be made up of several triangles. You could approximate a circle by using a regular polygon with a large number of sides. You could create something like a line with rounded edges by using triangles. And it's important to know a little bit of math for stuff like this. Trigonometry is very important, and you will also want to be familiar with vector math, which is also very important. And finally, linear algebra, which is very useful when you want to do transformations in 3D, like rotating objects and changing a frame of reference. Although there are math libraries that will help you with this kind of stuff, even though you might not know the full details of linear algebra, there are things that will help you with it in a more conceptual way. For example, there's libraries that can help you create a rotation matrix without having to construct the matrix from scratch yourself. How would we create a hexagon using triangles? This figure represents the general structure of a regular polygon. As you can see, there's 6 points on the edges of the hexagon, and there's one at the center, which is shared by all of these triangles. The center vertex is shared by all of these triangles, and then the vertices on the edges of the hexagon are shared by 2 successive triangles. In order to help with the construction of this polygon, we can label our points from 0 to n-1, where n is the side of the polygon, in this case from 0 to 6. So O is the origin, and P0, P1, P2, P3, and so on are the ring vertices. And it helps to use polar coordinates in anything that looks circular, we can represent these points using a radius and an angle instead of directly representing them in x, y, and z. So the ith vertex in our polygon has a radius of r, which does not change between these vertices, and then the angle theta I, it increases as we move around in a circular fashion. So if you take a look at one of these individual triangles, it has one vertex, which is the origin, and then the two other vertices are pi and pi plus 1. The first triangle would be composed of points O, P0, P1. The second triangle would be O, P1, and P2. And also take a note of the winding order of these vertices when we're composing the triangles. For example, on a left-handed system, the first triangle should be specified in the order 0, P1, and P0. The second triangle would be O, P2, and P1, and so on. Let's start writing the code for our regular polygon. The first thing I'm going to do is move this triangle mesh into a separate class so that we can reuse this and not have to create another similar class. And the IDE generally provides refactoring methods to move this to a new file, but you could also do this manually by going to Unity, create a new file called triangle mesh, because that's the name of the class, and then I can open that in my IDE and move this code from the triangle generator, and now this new file will just contain this triangle mesh class, and then we can start using this in our new generator. Let's start by creating a new class for this Polygon generator. So I will right-click, new C# script, call it Polygon generator, which is a new empty behavior, and then I can copy the scaffolding from this previous triangle generator. We need this required component so that we have access to a mesh filter and a mesh renderer, and then the code to populate the mesh into the mesh filter and assign a material to the mesh renderer. So I'm going to go ahead and copy that as well. And of course, we need a mesh to contain our data for the geometry. Which is a triangle mesh, and then I also need this material property. So we have this scaffolding ready for creating our polygon here. In order to create this polygon, we first need two parameters that define the polygon. The first one we need is the number of sides of the polygon. I'm going to call it side count. The second thing we need is the radius, which is a floating point number. So now that I have defined these two parameters, let's start by creating the vertices for our polygon, which goes into the vertex array. So we know that the origin or the center is shared by all triangles, which is, I'm going to call it O, and the coordinates for this is 0, 0, 0. And we need to create however many sides we have. Like for hexagon, we need 6, and this is going to be a for loop, which starts by side number 0, and then the count of sides. So this will run these many times, and we're going to use polar coordinates to construct these vertices on the edges. So let's start by defining the angle for each vertex, and we're going to use radians. So the full circle is 2 pi, and there is a class called mathf which provides this constant So we have 2 pi divided by the side count. And then, so this will be the step in angle, and we can just multiply this by the side to get the angle for each vertex. And the radius is constant, and the formula for converting polar coordinates to Cartesian, like from r theta to xyz, is just simply taking the cosine of the angle on x and then the sine of the angle on y, or z in this case, because we're trying to create a polygon on the xz plane, and then multiplying it by the radius. So it would be something like this point is new vector 3, the x component is radius times math f dot sine of the angle, the y is 0, and the z is radius times, sorry, I made a mistake here, the x is the cosine of the angle, and the z is the sine of the angle multiplied by the radius. So we have coordinates for the s vertices as well. Let's make sure to add these to our list of vertices. The first thing to go in here is the origin, and then as we create new points, we will add all of them as well. Now our vertex array is complete. Now that we have our vertices, let's go ahead and create the triangles, which is going to be another for loop with the same number of executions, which is it goes from 0 and it ends at side count -1, because that's the number of triangles we have. And we need to be careful about the order of vertices when we're specifying the indices. So this is Unity, which uses a clockwise winding order, and that's what describes whether the triangle is facing front or back. If you were doing this in 3JS, you would be using a counterclockwise order. So we're creating the triangles, and let's take a look at how the indices of these vertices are specified. The first point, which is the origin, was the first thing to go into our vertex array. So the index for this is 0, and then the index for the ith point will be, it starts from 1, so it would be 1 plus I. And then the index for the next point on any given triangle, it starts from I, and we add I plus 1, but we have to be careful not to go beyond the bounds of our array. And notice that the last point on the last triangle is also the first point on the first triangle. So we can kind of loop around this by taking a modulo by the number of sides. So let's use this information to do our triangulation. And what about the winding order? So if you look at any given triangle on a clockwise order, if we start from the origin, the next point is actually I plus 1. And then the third point would be the ith point in the vertex array. So let's use this to create our triangles by adding to the indices array. The first point is always at the 0th position in the vertex array, and then the next thing we're going to add is pi plus 1, and then the index for this is starts from 1 and then I plus 1 modulo of the side count. And then the third point on the triangle is pi, which is 1 plus I. That is the index of this triangle. So I'm going to leave a comment here. This is pi plus 1 and this is pi. So we have now created our vertices and our indices. This completes the geometry, and we already have the boilerplate code for feeding this into Unity from before. Let's go ahead and see if this actually works. So I'm going to create a new object, new empty object. I'll call this Polygon, and I'm also going to move this to the global origin, which is 0, 0, 0, so that it is nice and centered. And then I will add the new script that we created, and I can search for by Polygon generator. It shows up here as a C# script, and then now we can see that this has 3 parameters: the material, the side count, and the radius. I'm going to assign the green material that we created before, give it a side count of 6, give it a radius of 1. So I've specified the properties, and I'm going to hit play, go back to the scene view, and oops, looks like I double clicked on it. And now we have a hexagon. Now we can try changing the parameters of this script. For example, instead of a side count of 6, if I have a side count of 32 and I hit play, it's going to give me a circle that is much more rounded. And Unity has different views that you can use in this toolbar. If I click on this shaded sphere, it gives me options for a wireframe shading mode or a shaded wireframe. This is a great way to debug the geometry that we just created without having to change the material. And we can zoom in and zoom out, move around, and see the exact triangles that were created. And notice that if I look at this from the bottom, it appears transparent. And the reason for that is backwards facing triangles are not rendered by default in Unity and in most 3D environments. And this is, again, where the winding order becomes important. So chances are that if you generated something and you see something like this, you don't see any triangles, it's possible that you may have made a mistake in the winding order. You may have used a counterclockwise instead of a clockwise winding order. And I do that all the time. It's a very common mistake to make and something to keep note of. So far, we've only created 2D objects, a triangle and a polygon, or something like a circle. Let's make something in 3D. And a cube is one of the simplest things we can make. And this diagram shows how you can break a cube down into its component triangles. It has 6 faces and 8 vertices. And we can label these vertices as A, B, C, D, E, F, G, H, or 0, 1, 2, 3, 4, 5, 6, 7. Those would be the indices when we add these vertices to the vertex array. It helps to visualize the cube in your head, to kind of imagine looking at it from one side or the other side, because that's how we're going to figure out what is clockwise and what is counterclockwise. I'm going to create a new class called Cube Generator. Open this in my IDE, and I will copy everything from our Polygon generator, then paste it here. Make sure that I have the class name correct, and get rid of everything that we had from the Polygon generator, and this is where we're going to create our cube. Let's start by adding the vertices. So I'm going to start by adding these vertices one by one. So we have these vertices in our vertex array. Let's also go ahead and add the triangles, and we're going to use our diagram as reference with the winding order to make sure that we have the correct winding order. And I'm going to simplify this by adding an entire array at a time instead of adding it one by one. So we'll do this one triangle at a time. Cool. Now we have all of our vertices and triangles added. Let's go back to Unity and see if this actually works. So I'm going to select the triangle and the polygon from before and disable them on the inspector. And I will create a new empty object. I will call this cube. And it's at the origin, and I will add a new component, which is the brand new cube generator. And actually this side count and radius, I forgot to remove these two properties which we're not using anymore. So I'll just go delete them from the cube generator. The only thing we're going to be needing here is the material. So I will select the cube and drag and drop this material to the cube generator and hit play. So if I go back to the scene view, we have a cube with one corner at the origin, and this is exactly what we wanted. We have generated a 3D cube, but it is not quite complete. As you can see that the lighting on this cube is not very realistic, even though we have a light on the scene. For comparison, I will create the default cube from Unity, and I will move it slightly to the side. And as you can see on the Unity cube, some of the faces are darker and some of them are brighter, depending on which one is facing the light. But in our cube, there is no sense of lighting at all. And in order to fix this, we will need to learn a few more concepts, which is normals and vertex attributes, and how that information is used in shaders to calculate the amount of light hitting a surface, which will be the topic for the next tutorial.